In this video, we're going to practice reading function tables. We'll begin by evaluating f of 9. Since the value of x is supposed to be 9, we'll drop down to the row that has 9 for the value of x. Since we're trying to evaluate f of 9, we need to move to the appropriate column, which in this case is the second column, which is where f is defined, and we'll find where the row and the column intersect, which happens to be -4. Therefore, f of 9 equals -4. Our second example is evaluating g of 4. We'll begin by dropping down to the row where x equals 4. We will now move to the third column in which g of x's are defined and find where the row and the column intersect, and the value of g of 4 is -3. The next two examples will be compositions. We'll begin by doing f of g of -3. Recall, you need to compute g of -3 first and take that value and plug it into f. We'll define g of -3. We'll move to the row that has -3 for the x. We'll move to the last column where g's are defined, find where they intersect, and we'll come up with -7. This is not the answer. This is the expression that needs to be plugged into f. So we'll do the whole process again, except this time we'll move to where x is equal to -7. We'll move to the second column. We'll find where they intersect, and we come up with 0. So again, our final result, f of g of -3, equals 0. So if we're going to do g of f of 0, we're going to find f of 0 first. So go to the row with 0, go to the second column, find where they intersect, come up with 15. Take that value of 15, plug it into the g function, which means we'll have to go to the very bottom row in the very last column, find where they intersect, and you'll come up with a value that equals 4. G of f of 0 equals 4. The next two examples will be inverses. We'll begin by doing f inverse of 7. Remember, an inverse is where the x and y roles switch. So what was once your output is now your input. So we'll begin by going down the column of f of x and finding 7. That was an output. Now that becomes our input. Our input is actually the output, so we'll actually work backwards and find that the value would have come from 15. So f of 15 equals 7, f inverse of 7 equals 15. Next up will be g inverse of -4. So we'll find where g output was -4, in this case right here at the beginning, and we'll move our way backwards to the value of x that would have been inputted, which was -7. Therefore, g inverse of -4 equals -7. We're going to go back to the beginning and we're going to find f of x, except this time x is not any specific value. We're asked to find all values of f of x, which means we're going to have to go through the whole column of x and the whole column of f of x and define all those points. Our first point would then be -7, 0, followed by -6, -3, -4, 9, -3, 4, 0, 15, 4, -6, 7, -7, 9, -4, and finally 15, 7. And that is f of x. G of x will require us to go through the first column and the third column. And we'll say -7, -4, -6, 0, -4, -6, -3, -7, 0, 7, 4, -3, 7, 15, 9, 9, and finally 15, 4. If we are asked to find f of g of x, we have a long process in front of us, because first we need to realize we have to take every value of x. We then have to map, and I would highly recommend using a map when organizing your work. We have to map all those values of x to their appropriate g values. So -7 will go to -4, -6 will go to 0, and so on until we get 15 going to 4. Now those g values that were the outputs now become the inputs when we plug them into f. So we'll have to take -4 in the first column, realize that maps to 9 in the second column, just like we need to go 0 maps to 15, and we're going to have to do this all the way down until we go 4 maps to -6. Your composition is where you begin and maps to where you finally end. So you started at -7, you ended at 9. That's your first point of the composition. -6 gets mapped to 15, -4, -3, negative 3, 0, 0, negative 7, 4, 4, 7, 7, 9, negative 4, and finally 15, negative 6 represents the composition of f of g of x. Let's do another composition, this time g of f of x, which again requires us to map all the values of x in the first column, this time to the values of f of x, which are in the second column. So we'll begin by saying negative 7 goes to 0, negative 6 goes to negative 3, continue on until we get to 15 goes to 7. Once again, your outputs now become your inputs. So we're going to have to start back at the first column, find where x equals 0, and move all the way to the g column, which says that g of 0 is 7. We'll do negative 3 and map it all the way to negative 7. And finally, 7 becomes 15. So when we go through the points, negative 7 starts our first point, and we end it at 7. And then we go negative 6, negative 7, negative 4, 9, negative 3, negative 3, 0, 4, 4, 0, 7, negative 4, 9, negative 6, and interestingly enough, 15 maps to itself at the end, 15. Finally, we come to inverses. This process will be nicer than, let's say, compositions. It's actually quite similar to finding f of x, just think of it doing it backwards. So if we're going to find f inverse of x, realize that what was once our output of f of x is now going to be our inputs. So we'll begin at the second column. We'll define all those as our inputs, 0, negative 3, 9. All we need to do is then work backwards to the original x value. So if we begin with 0, we're going to end with negative 7. If we begin with negative 3, we go back to negative 6. And then 9 becomes negative 4, 4, negative 3, 15, 0, negative 6, 4, negative 7, 7, negative 4, 9, and 7, 15. One last time, g inverse of x. Start in the last column. Begin with the value of x being negative 4. Work your way backwards to the x column, and you'll say negative 4, negative 7. You'll start with 0, you'll end with negative 6, going from right to left when you read the table. And you'll have negative 6, negative 4, negative 7, negative 3, 7, 0, negative 3, 4, 15, 7, 9, 9, and finally 4, 15.